Okay, so previously we looked at one-dimensional arrays, which essentially looked like one row of data. A two-dimensional array then is an array that contains both rows and columns of data. So we can have multiple rows here in a two-dimensional array, and essentially it looks more like a table than anything else. As with a 1D array, a 2D array can only hold values of the same data type. So we can have a two-dimensional array that holds all strings, or all doubles, or all ints, but we can't have a mixture of both in the same one. Let's jump straight in and take a look at declaring a two-dimensional array of integers called R. And again, R is just the name I've chosen for this example. To declare an integer variable, we use the keyword int, and then we give the name of the variable or the array. In this case, it's R. And to show that it's a two-dimensional array, we just add a second set of square brackets. So two sets of square brackets denote a two-dimensional array. One for the rows and one for the columns. And that gives us our two-dimensional array. This particular array needs to be created with 3 rows and 4 columns. So we say R equals new int 3, 4. So the number of rows in the first set of square brackets and the number of columns in the second. So watch out for that. It's important to remember the first set of square brackets refers to the number of rows and the second set refers to the number of columns. So you'll see here in my example I have 1, 2, 3 rows, but we have 1, 2, 3, 4 columns. Each value again has its own index. So in this instance our columns are 0, 1, 2 and 3. And our rows are 0, 1 and 2. Therefore, if I wanted to access the top left-hand corner, the index would be 0, 0. So the row number followed by the column number. Let's take a look at an example. If we wanted to assign the number 9 to the first index in the row of the array, we need the name of the array followed by the index. So we have R 0, 0 equals 9. That one's straightforward enough, and it pops the number 9 in here. Supposing we wanted to assign the number 7 to the fourth index in the second row of the array. Okay, so the second row is going to be 0, 1 is the index for the row, and the fourth index of the columns is 0, 1, 2, 3. So R 1, 3 equals 7. Again, here I'm only assigning integers, so I don't have any quotes around them. If I was dealing with strings, I would have quotation marks. And that pops the number 7 in here. As with one-dimensional arrays, we can do all of this in one line of code if we want to declare, create and assign values all in one line of code, assuming we know all of the values that are going to be stored in the array in advance. So this example asks us to declare and create a 2D array of integers with 3 rows and 4 columns called nums, and at the same time to assign the values 9876, 6543 and 3210 to the array. So if we know all of the values in advance, it's possible to do this in one line of code. And that line of code is int nums with 2 sets of square brackets to show that it's a 2-dimensional array. Then we have one large set of curly brackets to hold all of the different rows, and then each row gets its own set of curly brackets. The first row there is 9876, each separated by commas in its own set of curly brackets. That set of curly brackets is then followed by a comma. Then we open the new set of curly brackets for the next row, where we have 6543. That set of curly brackets is followed by a comma, and then we have our last row with 3210 in it. And our final closing curly bracket to close the entire set of data for that particular 2-dimensional array. And what that does is it gives us an array called nums with 3 rows and 4 columns, each with all of the data stored in the appropriate index. So we've managed to do it all in one go in one line of code. Similarly to a one-dimensional array then, what can be really useful is to be able to traverse the array, okay, a 2-dimensional array. Again, we can do this using loops, okay? And we would do this to carry out some sort of action, be it print all of the contents or assign a value or whatever it happens to be. And we do it using a nested loop for a 2-dimensional array. So for example, let's traverse an array called R with 2 rows and 3 columns to print the content of each index. The outer loop here is to do with the number of rows. So our I value counts the number of rows. So if I want 2 rows, I declare int I equals 0 and continue so long as I is less than 2. And then I increment my I++. Within that then, I have another for loop, but this time I'm using the counter j. I'm using the counter j because the counter I is still active. And if I try to use I here, they're going to interfere with each other. So I use j because it's the next letter in the alphabet. That is the only reason. I could use x and y, I could use or and c for rows and columns. It's completely up to yourself, so long as they're 2 different variables. So here we declare int j equals 0, continue so long as j is less than 3 because we want 3 columns, and we increment our j++. To print the content of each element in this array, we have jOptionPane.showMessage dialog, null, comma, then R to refer to the array, and I in the first set of square brackets and j in the second. So first time through this loop, I will be 0 and j will be 0. Then the inner loop repeats, so j becomes 1, and we print R 0, 1. The inner loop repeats, and j becomes 2, and we print R 0, 2. Then the inner loop is finished, so we come back up to the outer loop. It increases. We come back in, and j is reset to 0, and we print R 1, 0. J then increases. We print R 1, 1. J increases again, and we print R 1, 2. The inner loop completes. We go back to the outer loop. I becomes 2, and it realizes, wait, we've finished that loop as well, and we've printed all of the contents of the 2-dimensional array. So that is how we traverse an array called R with 2 rows and 3 columns and print the content of each index. Again, sometimes we may not know the number of rows and columns in the array. In this case, we use the length field in the outer loop to count the number of rows, and again in the inner loop to count the number of spaces in each row. And this is how that looks. To apply it to our previous example, our outer loop, the I initializes at 0 and continues so long as I is less than r.length. And that's similar to how we saw it earlier on. When we get to the inner loop, however, we want to get the number of spaces in an individual row of the array. So our j is less than ri.length. So we're referring to a particular row and asking it to find the length of that particular row. So it's one tiny change, but it allows us to traverse a 2-dimensional array of unknown size rather than always having to know how many elements are in the array. The print statement remains the same. We're still printing rij. So let's take a look at a coded example for this one then. Develop an application that saves the daily millimeters rainfall over 4 weeks as follows. Week 1, 2432114. Week 2, 5312134. Week 3, 3323112. And week 4, 2133211. So for each of the weeks we have 7 different values and we need to store these in a 2-dimensional array. So we have 4 weeks with 7 values in each week. The application should then print the contents of the array to the user. And we're asked to save this application as rainfall1.java. So let's switch over to TextPad and try this one out. Okay, so here in TextPad I've created a new file and I've saved it as rainfall1.java, and I've put my comment at the top with the name of my file, the author and the date. Again, we're going to just do this as though it's an app class, alright, and so that we can see the operation of a 2-dimensional array. So we start this one, public class, rainfall1, public static void main string args. We haven't been asked to get input from the user here. We've been asked to declare, create and assign the values to the array to start with. So int, and we'll call the array rainfall this time. 2 sets of square brackets to denote that it is in fact a 2-dimensional array. Then we open our curly brackets. Inside the curly brackets then we have a set of curly brackets for each week. So 1, 2, 3, 4. If you're inclined to get yourself muddled with the curly brackets, do it this way, get them all in there first. Inside the first set of curly brackets then I put my first set of numbers separated by commas. So 2, 4, 3, 2, 1, 1, 4. The next set 5, 3, 1, 2, 1, 3, 4. The next row 3, 3, 2, 3, 1, 1, 2. And finally 2, 1, 3, 3, 2, 1, 1. That should declare, create and initialize our array of rainfall data for 4 weeks. Then we were asked to loop through that and to print the content of the array to the user. Now I'm just going to print this using system.out.print rather than use a JOption pane, so we're not having to click OK every time we get a value printed to the screen. So to loop through this, we're going to use our nested for loop, int I equals 0, I less than. Now we know there's 4 weeks, so we could say I less than 4, or we can say r.length. And then I++ to increment. Inside that then we have a new loop for int j equals 0, j less than. Again, we know that we have 7 days in a week, so we could say j less than 7. But in this instance, I'm going to just say j less than r I dot length. Okay? And then we increase j++. Inside that then, we simply want to print the content of rij. So system.out.println, well, not even println, just print rij. Close our brackets and our semicolon, close your inner loop, close your outer loop, close your main method, and close your class. So Control and 1 will compile this. And we have 3 errors. The first error here is saying cannot find symbol r. Oh, that's my fault. I've named my array rainfall. So it shouldn't be r.length, it should be rainfall.length. And here it shouldn't be ri.length, it should be rainfall.i.length. And similarly when I'm printing, it shouldn't be rij, it should be rainfall.ij. That was my mistake. Apologies for that. Control and 1 are now complete successfully. So Control and 2 prints the content of each row straight across. Now supposing we wanted to see it 1 week at a time. So if we wanted each week on a separate row. The inner loop prints one particular row. So after our inner loop, but before we close our outer loop, we can add a system.out.println with empty brackets. And when we compile and run this, you'll see the effect it has is that it brings each new week to a new line. So it's going to print the content of each row using the inner loop, and then it's going to skip to a new line before printing the content of the next row. So that's how we traverse a two-dimensional array using a nested for loop with our I and j counters, and using our length method for the length of the number of rows and for the number of columns within each row.